Or yesterday, Friday, we worked with confidence intervals. With that confidence interval, though, we started talking about sample size that was smaller than a value of 30. And what we had to go into is what is a t-table to be able to calculate our confidence interval. Our confidence interval is equal to whatever our sample mean is, plus or minus our t or z for the confidence interval, times the standard deviation, divided by the square root of n. When I have a sample size that is less than the value of 30, I'm going to be using for the t. When I have a sample size that's greater than or equal to the value of 30, I'm going to be looking at the z for the confidence interval. And once again, your t-table I handed out on Friday. The t-table I handed out on Friday gives us both of those values, the z and also the t value. If you look at the bottom of the table down there, you'll see that you have a z value. And once again, you can use the 3 decimals or you can use the 2 decimals. Does not matter if you use 1.645 or 1.65. You can use either or. Questions you have on anything on the worksheet? Yeah.
Do you have an extra chart for that?
Yeah. Once again, nothing very difficult here, but you still need to keep up with the material. All right, today we're going to deal with proportion, which is basically your percent. Your surveys that they do for the elections, they give you the percents. That's the step. That is the idea of a proportion. A proportional amount or a percent amount. If we go back to our binomial probability, we had some values that we used in regards to calculating a binomial probability. Binomial probability was you either hit or you miss a free throw. You either got something right or you got something wrong. There's a probability that we dealt with that just you had 2 solutions, right or wrong, make or miss, whatever that is. And the variables that we utilized was Q was the probability for failure, P was your probability for success, N is your number of trials, X is the number of your successes, and the probability that we calculated for the number of successes that we had is NCX, P to the X, and then Q to the N minus X. P to the number of successes, probability of success, number of successes, probability of failures, and number of failures. Okay, that was what we talked about and dealt with when we were dealing with probability. Now, what we want to be able to do is we want to be able to come up with a confidence interval for a percent of this probability or binomial probability or the election results. We take a look at those election results. We want to be able to determine how do they calculate those percentages. Well, we can still deal with a point estimate with a population proportion for success. This is called P hat. Put a little dome on top of it. This is called P hat. It is your population estimate. It's the point estimate. It'd be like your sample of the average number of whatever percent of for or against a certain thing. It's called p hat. How we calculate our p hat? Once again, we're looking at a sample. We're looking at a sample. We calculate the number of successes divided by the total number in the sample. So this is for a sample. Suppose I was polling this room, the number of people that ate breakfast this morning. And I was polling this room. Well, and then I want to be able to determine for this entire school how many people, what percent of people ate breakfasts this morning. So I would do a sample of this room, and the number of people would be the total number of people I have in this room, which is 23 people in this room. That would be my end value. The number of people that actually ate breakfast this morning would be your number of successes. Okay, and that would be a sample for just this room. But then we can utilize our percentages and say, what would it be for the entire school? Q hat is your population proportion to point estimate for the, again, we're talking about point estimates for your population or for your sample. It is your probability for failure. And how we calculate that is 1 minus p hat. So we have a total of 22 people in this room right now. Let's say 15 of you ate breakfast. So our p hat would be 15 divided by 20. So if I would quickly collect that through the calculator, I can calculate my population for success. Going to 2 decimal places would be fine. 15 divided by 20, 2.
0.68.
That would be 0.68. So of my sample in this room, 68% of you ate breakfast. The percentage of people that did not eat breakfast would be 1 minus p hat, which would be 1 minus 0.68, which would be 0.32. So you would have 32% of you would not have eaten breakfast. This is some data from way back. Survey of 1,500 U.S. adults. Survey asked 1,500 U.S. adults if they will participate in the 2010 census. 1,215 U.S. adults said that they will participate. Calculate p hat and q hat. Well, my successes is what I'm looking at is the subject. Are they going to participate? 1,215 people said they are going to participate out of the total of 1,500. So once again, we can take these to 2 decimal places. Noah, what did you come up with? 0.81. Q hat is 1 minus p hat. So we have 1 minus 0.81. So we get a 0.19. 81% of the 1,500 people said they're going to. 19% said they were not going to. But what they can then do with that sample of 1,500, they can go to the entire United States and guesstimate how many people are going to be a part of the 2010 census. Our air. How we calculate an air. Our air E is calculated by the Z for the confidence interval times the square root of P hat times Q hat divided by N. When we're dealing with this air for a population proportion or a population, this was Z for the confidence interval or T for the confidence interval times the standard deviation divided by the square root of N. Now we got P hat times Q hat divided by N, and we take the square root of all that. The population proportion P, once again, this is a population. P hat and Q hat are your point estimates. It's like your sample. How we can calculate a confidence interval for this value of P. And this is what the people do when they do surveys for the elections. They survey 1,000, they survey 2,000 people. Who are they going to vote for? And then run a confidence interval. They calculate an error and run the confidence interval for the actual population. Population portion P, probability of success is calculated. P is going to be somewhere between P hat minus E and P hat plus E. And once again, how we calculate our E value. We have our Z for the confidence interval. We use our Z value.
Sorry, I forgot to give you yours.
Thank you. We have our Z for the confidence interval because we're talking about a large population here. Hopefully our sample size is going to be less than or more than the value of 30. If we're going to predict out an election in the state of Ohio, predict out an election in the United States, hopefully we have more than just 30 people that we're choosing. Survey of 1,500 US adults. This goes back to our previous question, 1251. Our 1215 said they'll participate. We did P hat and Q hat. Let's construct a 90 or 95%. Let's just do it. Yes, we'll do both of these. 90 to 95% confidence interval. Okay, we calculated P hat, 1215 divided by 1,500, 0.81. Q hat was 1 minus P hat, which is 1 minus 0.81, 0.19. Okay, we have a 90% confidence interval. So we need to look at a Z value for a 90% confidence interval. Once again, we can go to our t-table, drop our t-table down to the bottom because we're looking at our Z value. And once again, if you look at the very left-hand column of that, it has Z and an infinity there. That gives us our Z value. Anybody else take one?
No, I said I forgot one.
For your reminders for. Our Z for our confidence interval for 90%. What is it?
1.645.
And once again, if you use 1.65, that is fine. We calculate our air. We calculate our air, which is our Z for the confidence interval, square root of P hat times Q hat divided by N. So you want to take this to 2 decimal places. So we have 1.645 times the square root of 0.81 times 0.19 divided by 1500. Don't do the second one. We're going to do something different. The second one, 95% one. Once again, your calculator, if you have a TI calculator, it will set you up nicely in regards to you could just go 1.645 times the square root of 0.81 times 0.19 divided by 1500. Pull out of the radical. Once again, go to 2 decimal places. Rachel, what do you have to 2 decimal places? 0.02. So our error is 0.02. So our population proportion will be somewhere between p hat minus this error and p hat plus this error. So we have p hat, which is 0.81, minus 0.02, and 0.81 plus 0.02. So we have 0.79 and 0.83. So we are 90% confident that between 79 and 83% of the people will participate in the survey and the census. Okay, let's go to 95% confidence interval of people that we eat breakfast. We did a sample here. Our p hat was 15 out of 22, which came down to 0.68. And our q hat is 1 minus our p hat, which is 0.32. We want to do a 95% confidence interval of the people in the school that we eat breakfast today. So let's find the Z for 95% confidence interval. So we can look at our table. So we go 95% along the top, we drop it down to the very bottom. Should get a 1.96. So we calculate our error is the Z times square root of p hat times q hat divided by n. Calculate your error. Then you have your p hat minus your error. And p hat plus your error. Now, this error might be a little bit larger here, and the reason why is our sample size is not very big. Our N is only 22. If we would increase that sample size, that would give us a better result. And that's what you get for an error. Huh? 0.19. So we have our p hat plus this error and p hat minus the error. So we have 0.68 minus 0.19 and 0.68 plus a 0.19. So our two values that we come down to are what, Justin? 0.49. So with being a small sample size, is only 22, we're not going to be very close with our population, but with our sample that we have, we can guesstimate that anywhere from 49% to 87% of people at Dalton High School ate breakfast. Let's do the 99% one here. Survey 1,023 U.S. adults, 552 say they have worked the night shift at some part of their lives. Construct a 99% confidence interval for the population proportion. So calculate your P hat, Q hat, get your Z for your 99%, calculate your error, and form a population proportion percent confidence interval for the percent of people that have worked a night shift. Check your answer with somebody around you. Trigger P hat at 0.54, Q hat at 0.46. 99% confidence interval. We have 2.576. So we calculate an error. Cindy, what do you get for an error?
0.04.
0.04. So we have P hat, or P hat minus and P hat plus. So our population proportion will be somewhere in between 0.50 and 0.58. So we can guesstimate that anywhere from 50 to 58% of the people in the United States has worked a night shift. Okay, once again, this is your error. This is your error that we have talked about. The population or the percentages that we talked about with respect to election in Virginia had an error of 0.04 or 4%. They added and subtracted that 4% from either side. That's what we're doing here. We're adding and subtracting our 4%. And that's how they do population election surveys. This is what they do. People get paid to just call up, make random phone calls, or to now send out surveys in regards to presidential elections, any type of political elections at all. They send out these surveys, they collect the data from these surveys, and then they send out this data and do their calculations and send it out to, they post it and send it out to news media outlets. So it's basically what people get paid to do. I have a worksheet that has 4 problems on there that deals with confidence intervals for the population proportions or your percentages. Make sure that you get a statement down at the end of each one of the problems. Get used to the statements. You have about 15 minutes, a little over 15 minutes of the class here. Use your time wise. I could probably get it done here in class.